Welcome back. This time we're going to be recreating this children's toy. These are very old toys that existed before the days of internet, TikTok, and memes and Game Boys and stuff like that. And I don't know if they're better than the internet, TikTok, memes, and Game Boys, but they are certainly quite fun. If you turn this upside down and then the right way up, it makes a mooing noise. They were very common. I had one. I bought it from a farm shop or something. But we're going to go ahead and recreate this inside Neos. This came about from a friend of mine called Erin who was playing H3 VR, and they have a bunch of these inside the game with different sound effects. And so they wanted to make it inside of Neos. They asked me to make a 3D model. I did that. And we made it work. You can find it in Erin's public folder. I will give a link to that in the video description. There's also an editor, so you can make your own sound effects and stuff like that. I'll show that off at the end. But for now, we're going to go ahead and recreate this object using much simpler geometry and just talk you through how I made it and how it works. Well, how Erin and I made it and how it works. So I'm going to put this one off to one side, hop over here into Smooth POV, and we'll get started with making this. So we're going to grab our developer tooltip, and the first thing we need is the body. In this case, we'll just use a cylinder. It looks near enough the same. That's just got some holes on the top and some smoothing. So we'll do create new cylinder. We'll inspect it. And I'm going to enter into height. I'm going to enter 0.1. And radius, I'm going to enter 0.1. As always, if you're using a procedural mesh, please, please, please do not edit the scale. The scale should be 111 for procedural meshes. You can edit the properties of the procedural mesh here, and then you avoid things like non-uniform scale. There's a link in the video description about non-uniform scale. With this created in the world and the gizmo here, we actually have an interesting way to talk about it. So what we need to do is detect that this cylinder was grabbed, turned upside down, and then the right way up, and then we can play a sound. Now, those of you who are sat there and thinking, I know how I could do that, I would use rotations. You're right, and that was what Erin's first attempt was. So if I grab the cylinder here, spawn a Logix interface card for it, they'd probably look at the rotation value here. But I opted for something simpler, and I wanted to explain those nodes to Erin and now to you, just because I don't really like these things. I don't know how they work, they're maths, they're scary. Let's do something a little bit simpler. So in a previous video, actually the previous one to this, which will be sample color, and a previous video a few weeks ago called slot direction nodes, I talk about the slot direction nodes. If you'd like more information on those, do check the video links for that video. But I'm going to recap one in particular, which is the up direction node. So if I go ahead and go into the node browser here, and I go into transform, and I look at the up node, and I plug this into our slot card here, you'll see that we get roughly Y1, and the rest of the numbers don't really matter. They're just because it's not entirely level. In fact, if I level this off, you'll see it's now 1 in the up direction. What this is referring to is the blue arrow coming out of this cylinder. You can see it's pointing up. And this is the up direction of this cylinder. Actually, this slot, but the cylinder's on the slot, so same thing. What we can do, instead of dealing with rotation, is we can just look at how this up value changes. So when this cylinder is upside down, its up value is negative 1, and when it's the right way up, its up value is positive 1. And so we can use that to basically be like, hey, is this upside down? The important thing to note here, though, is that we want to make sure that we compare this to something else in the world. This just means that we have our sort of sense of what is actually up in the world correct. Now, we could use the world up here, but we're going to go one step further and make this work in zero gravity. This is an extra step that I don't see many people do in their creations, but do remember that we're seeing an increase of gravity-defying worlds. I was one of the first that was published. The moon landing was the one that I did, but now Baxter is kind of leading the way. They're using the name Baxter. They keep publishing weird and crazy gravity worlds. There's also one called Donut Planet or something, which was an MMC entry, which has sort of toroidal gravity. That's a long sentence. It basically means you can walk around the outside of a donut and the inside of a donut, and you stick to it like gravity. And making this object work in all of those worlds, it was strangely a priority, and it also allows me to talk about some cool nodes we haven't used before. So let's go ahead and do that. To do that, we'll need to change our reference point for up from being the world to being the user holding it. So if they're upside down, you still have to turn it upside down relative to them. So the easiest way to do that is to go ahead and look for the slots, get active user self. Now, get active user self will return the user that is holding the object in this case. So at the moment, no one, but when I'm holding it, it will be me. And then we're going to get my root slot. Let me get rid of these gizmos because they're interrupting my view here. So user root slot. And then we'll need my up. So now we have two up direction vectors, and we can compare them. So we'll see, hey, I'm facing up, but hey, the cylinder here is facing down. Up, down, and we can compare these together. Now you might want to compare them using various nodes, but we're actually going to compare them using another node, which is the dot product. We're getting into a little bit of maths here, so I do understand if you guys tune out because maths isn't your thing. But if you go to operators here and you're looking for the node that's a dot, not this one, this is the circle node, I don't know what it does, but dot. I've been meaning to know what that one does. If you know what that does, put it in the comments section and think of a use for it. Often I hear what it does, but I don't have a use for it, so I forget. But here, the dot product is a common vector operation. It's used a lot in Neos. If you had access to Neos' source code, you would see it in quite a lot of things that are surprising. It's also used a lot in the shaders and the geometry and the rendering of all the things that you're looking at in a game, like any game. Like dot product is everywhere. But what dot product does is it returns a value that basically calculates the similarity between two vectors. So if we plug in both ups, we can get a value here, and we get 0.99, and that means they are damn near identical. In fact, if I level this off, you'll see 1. And what this means is the cube is facing up and you're facing up. Like they're 1-to-1 together, they're equal to each other. If I turn this upside down, you'll see that we get -1, or there or thereabouts. There we go, -1. That means that these two vectors are about as far apart as they could ever possibly be. So the dot product gives you a sliding scale from not like each other to like each other, where -1 is not like each other and 1 is like each other. 0 is also, I think, like completely, like, I think it's like if I do that, so on its side, we'll get 0. Yeah, that's basically 0. That means 0 with like 0 point and then 7 zeros and then 1. So yeah, that's basically 0. So it means like a 90-degree angle from each other. But we're only going to be worrying about 1s and -1s. So what we're going to be doing here is, first of all, detecting that this number went to -1. I actually need to keep it the right way up for the moment. There we go. We're going to detect that this number went from where it is now to -1. So for that, we can do fire on true. And we can say, hey, when this dot product here, when it equals 1, and we'll use approximately equal here. This node, approximately equal here, will help you out with floating point numbers. Floating point numbers have what's called floating point imprecision. That's why if I mess around with this a little bit, you'll see that, hey, it's got a lot of 9s after it. That happens a lot with floating points, more than me just playing with it. And so this node helps you out with that. It basically compares two numbers, and then you put in a third number, which is the epsilon, not epsilon, the user of Neos, the epsilon here. And this shows like, what is the sort of a range that they can be approximately equal to? So this means like, what's the give in that number? So if we put in the top A, and then we put for B, -1, and then for our epsilon, we'll do 0.01 should do. And then we'll put that into fire on true, and we'll hook up get active user self again, and then we'll use an impulse node here. Impulse display even. Now you'll see when I turn it upside down, we get that impulse. And when I turn it the right way up again, and go upside down again, we're getting more and more impulses. So this is basically saying like, hey, you've successfully turned it upside down. That's great. We've got the first half of this done. Now that it's upside down, what we're going to go ahead and do is we're going to toggle a Boolean latch. Now, a Boolean latch is just a light switch, basically. It's a light switch that exists inside of objects. So what we're going to do is, hey, when we detect that it's gone upside down, we're going to set this Boolean latch. And now what we're going to do is just repeat that, but with positive 1. So again, we check the dot product, and we say, hey, is the dot product +1 with that same epsilon? And we'll fire on true that with our get active user again. Now coming off here, this will be when we've turned it the right way up again. We want to go into if. And remember here, the if detects wherever value is true or false. And if it's true, it comes out here. And if it's false, it comes down here. If you'd like more information on the if node, do check a video linked in the video description. In hindsight, I should probably put these upside down so that actually, let's do that. Let's put this up here. The epsilon's the same, so I'll just push it through here. And we'll do it this way. That might make a little bit more sense. We've got right way up on the top, wrong way up on the bottom. So what we're going to do is check when it's the right way up again. Has it been the opposite way up? Has it been facing down? And that'll be if this Boolean latch is set, which we set when it's upside down. So when it goes upside down, we set this Boolean latch here to true. And then when it comes back up the right way, we can detect, hey, it's been true. This latch has been true, which means it's been upside down. And that means that our sound can play if this impulse plays. Let's test that without the sound, and then we'll add in the sound. So turn it upside down, and then the right way up again, and you'll see that goes off. But if I was like turning it to the side, then right way up, you'll see it's still going off, and that's because we need to reset this Boolean latch, and we'll do that after we've played the sound. So playing the sound, exactly the same as every other time I've played the sound. We go to audio, play one shot, and we say, hey, we're going to play when that impulse is fired. We're going to use audio clip input here. And we're going to grab this conveniently located sound effect, which I prepared earlier, which is that cow moving from the start of the video. For the point that we want to play it at, we're going to go ahead and use this slot here. Again, I'll push this through. And then after this sound has started playing, we're going to go ahead and just reset that Boolean latch. So, if all goes well, there we go. We've got our jar recreated. Now, there are a couple more things that we should do here. For example, we should do a local impulse timeout. This just means, hey, the sound can't continually play, because right now I should be able to just continually trigger it. Something in, yeah, there we go. And that could get a little bit annoying, so you maybe want to like local impulse timeout that so that it can only play, I don't know, once a second or something. And I should also configure the play one shot so that it has a localized audio space. There'll be more on that later when I cover how to do that. Most people get that wrong, but I am going to leave that off here because it's a topic for another video. There is your cow jar recreated. Now, I know that this stuff in the middle with the dot product might be a little bit more complicated than you're used to, but it's just an alternative option that exists, and that dot product node there is something that is just happening all the time around you, like shaders, physics, like the dot is being run more times a second than you can probably imagine in most 3D games. I don't really understand why in some cases, but for this particular case, I do. We're comparing the cylinders up to my up and seeing when they are sufficiently different to flick on this light switch and be like, yo, you turn me upside down. So there you go, that's how that jar was made. I do want to take some time to just head over to Erin's creation. I do need the sound effect back for that though. So this is Erin's creation for it. I'll link it to their public folder in the video description. This allows you to make your own ones. You can slot in an image up here. The image dimensions are a little bit weird. This, I believe, is 1920 by 540. That's just so I could get the cows lined up. I made this image from a stock wallpaper I found online. But if you have any image, you can just chuck it in there. So let's go back to our inventory and we'll go to pictures. Here's Fruks. So we'll take the cows out, we'll put Fruks in. You'll see it go black, that's because it's a transparent image here. And I can kind of crop this down a little bit to make it a little bit better on the... oh, that's more horrific. Let's see what we can do here. That's okay, but it still looks cursed. It's just because I don't have any images that are the appropriate dimensions. Maybe we can chuck this down to just their face. That might look a bit better. Oh no, it's just going to look horrific. And then you can replace the sound by just putting a different sound in here. So I'm going to be boring and just grab one of the test sound effects from Neos Essentials because I don't have any to hand. All right, Neos Essentials sound effects, UI, achievement.wave. There we go. And we'll put that in there. You hit create. And you've got yourself a brand new, incredibly stretched Fruks face achievement jar. So there you go. That's how we made that cow jar. I hope you found that interesting, particularly that mathematics that we did. I have never understood the dot product, but that finally got it for me, how similar two vectors are. I will put some links in the video description to more information about the dot product and also how prevalent it is in the game industry. And I will see you next time. Let me know if you have any questions in the comments. Bye-bye.